All right, guys. So we're going to talk about complex numbers. So first thing I'm going to do is just define a complex number for you. Then we're going to add, subtract, multiply, and divide complex numbers. So let's start off with defining the imaginary unit I. So that, simply put, is just defined as the square root of -1. So I is equal to the square root of -1. So now we're outside of the real numbers and we're into the imaginary numbers. So now let's take a look at what happens as you keep increasing the exponent of I. So you got I to the first power, which we know we just said is the square root of -1. Then we have I squared. Well, what is I squared? Now you see I have here it's equal to -1, but why is that the case? Because I squared is equal to I times I, which would mean the square root of -1 times the square root of -1, which is equal to -1. So that's where we get the -1 from here. Well, what is I to the third power? Well, that is I squared times I. So we already said that I squared is equal to -1. So this would just be -1 times I, which is -I. And then, of course, I to the fourth is equal to 1, because this would be equal to I squared times I squared, which would be -1 times -1, which is 1. So just proving why that is the case. And of course, once you get to I to the fifth, everything repeats, and that just becomes I to the first again, and so on. So it just keeps cycling between these four values. I squared is -1, I to the third is -I, and I to the fourth is 1. All right, so now a complex number is written in standard form when it is in this form right here, a plus bi, where a and b are both real numbers. And then I just gave you an example here. This is a complex number where this is our real component and this is our imaginary component. So let's go ahead and add and subtract. So looking at this first problem, number 1, we want to add these two complex numbers together. Really what we want to do is think about adding like terms. Well, what I can add together are the real components, and then I would add together the imaginary components. So this is the same as saying -1 plus 3 plus 2i plus 3i. And then what would that give me? This would be 2 plus 5i. So that would be the answer for number 1. Pretty straightforward. Now where you have to be careful is with subtraction, because we still have this minus before the parentheses, which means that we're going to need to distribute that minus. So then this, we're going to rewrite. We have 2 minus 3i. This becomes -3 plus 7i. Again, we have to distribute that minus sign first before we do anything else. And then we can go ahead and look at our real components and our imaginary components, and we can add those together. So that would give us -1 plus 4i. And that would be the answer to number 2. So addition and subtraction is pretty straightforward. It's not too bad. Let's look at multiplying and dividing. So here with number 3, you see we have this 5i times -2 plus I. Well, right away, you're probably thinking of distributive property, and that's actually what we need to do. So this is going to be 5i times -2 plus 5i times I. So that would be -10i plus 5i squared. Now remember back in the beginning, what does I squared equal? Well, I squared is equal to -1. So we can go ahead and say that this is -10i plus 5 times -1. We're replacing the I squared with -1. And then this would be -10i minus 5, which of course that is not standard form. We always put the real number first. So we would just say that this is equal to -5 minus 10i. So we have it in the proper form. And that is the answer for number 3. So then looking at number 4, we can see this looks like a binomial. Well, it is a binomial times a binomial, but you're thinking it's very similar to saying like x plus 2 times x minus 3. And that's exactly what we're going to do. Some students say FOIL. I always say distributive property. We're going to multiply 7 times negative 1, 7 times the 2i, and then negative 4i times negative 1, and then so on here. So when I do that, 7 times negative 1 is negative 7. And then 7 times the 2i is plus 14i. And then the negative 4i times the negative 1 is plus 4i. And the negative 4i times positive 2i is minus 8i squared. So now what we want to do is we have some like terms here, the imaginary parts that we can take care of, plus we can replace the I squared with negative 1. So this would be negative 7 plus 18i minus 8 times negative 1, which of course would become negative 7 plus 18i plus 8. Negative 8 times negative 1 gives the plus 8. And then we can finally say that this is going to be 1 plus 18i. And we are finished with that one. Now let's look at division. So here, we're just dividing the 4 plus 5i, dividing that by 3i. Well, there's really not much that we can do here, but we do have a problem because we have an I in the denominator. And we can't have I in the denominator and the expression considered simplified. So we got to get rid of that I in the denominator. Well, how can we do that? How can we get rid of that I in the denominator? Well, if you recall, I squared is equal to negative 1. So if I could somehow get this bottom to have an I squared instead of an I, then I could replace it with negative 1, and that would give me a number in the bottom, not have an imaginary unit in the bottom, which is in the denominator, which would be perfect. Well, I can do that by multiplying by I. And if I do that to the bottom, I have to do that to the top as well. So then this, when I multiply, would give me 4i plus 5i squared, remember it's distributive property here, over 3i squared. And then I can go ahead and replace my I squareds with negative 1s. So 4i plus 5 times negative 1 over 3 times negative 1. So then I'm going to go ahead and pull this to the front because we know that's negative 5. So I'm going to say negative 5 plus 4i, so it's in standard form, over negative 3. Now, chances are you're not going to see it this way, and you're probably not even, you're definitely not going to see it with a negative in a denominator. So basically, if we just divide everything by a negative, that would just give me 5 minus 4i over 3. I'm just saying that because you're really not going to see a negative sign in the denominator at all. They're going to go ahead and divide that all out so that it gets rid of it in the denominator. But we could also say this could be split up, so you have your real component and your imaginary, and this would be 5/3 minus 4/3 I. That's really the way you would put it in standard form, because you have your real part, you have your real part and then your imaginary part there. All right, let's look at the last one here. So now this is a little different because I can't just multiply by I. I cannot just multiply by I, because if I do that in the bottom, 1 times I is I, so yeah, I get rid of it over here, but then I create an I over here, so that doesn't help me. So what I need to do is to multiply by something that's called the complex conjugate. And what that is you're just going to multiply by the denominator, but changing the sign. Of course, you have to do that, whatever you do to the bottom, you have to do to the top. So this is called a complex conjugate. And the reason why we do that is because if you recall, when you multiply with the difference of squares, when they get back with polynomials, if you have like x plus 2 times x minus 2, what happens, the middles cancel out, the x term. So this just becomes x squared minus 4. So the x part in the middle is gone because it's plus 2x and minus 2x. Well, that's exactly what's going to happen here. The part with the I by itself is going to disappear. So I'm going to go ahead and just multiply that down over here. So then up top in the numerator, again, we're going to FOIL, so it's 5 times this and then times this and so on. So what that would give us is 5 plus 10i plus 3i plus 6i squared over, now when I multiply the bottom, I'm going to get 1 plus 2i minus 2i minus 4i squared. See what I'm saying here? This goes away, which we need that to. That's where the I is, and we're trying to get rid of it because we know we can replace the I squared with -1, which would then make the denominator just a real number. So then up top, we got 5 plus 13i, because we got these two right here. Those are like terms. And then plus 6 times -1 over 1 minus 4 times -1. And then I'll just bring it down over here. So this will become 5 plus 13i minus 6 over 1 plus 4, because minus a negative times a negative. And then from here, we have -1 plus 13i over 5, which is more than likely going to be written like this, -1/5 plus 13/5 I, which is your standard form there. All right. So hopefully this helps with the operations on complex numbers and kind of understanding, what is a complex number. This is just scratching the surface of complex numbers, but it definitely would give you a good start to understanding and working with complex numbers. And I'll definitely see you on the next video.